All right. So finally, we are at the slide whose title is same as your course. Okay, Cognitive Internet of Things, and we had all those lectures gone behind it to prepare us to be at this point so that we can appreciate or you can learn a little bit with more confidence. Evolution computing has been there since a long time, more than 100 years now. So we have been seeing it, and we're coming from this device to all the way. Now we are here. Okay. So the IoT age. What is the IoT age? The way internet impacted our digital world, the IoT is doing the same for physical world. So internet to digital world is IoT doing the same for physical world. And cognitive IoT is gone a couple of scales above that. We don't know what will be the impact till now. The cognitive solutions for IoT applications involves so many things like sensors, data, analytics, information, cognitive behavior, and knowledge. Okay? And this is all we call actually cognitive system when they combine a couple of them together with the expertise, of course. Okay? And almost all the cognitive systems, they collect data and information. And here are some of the examples, areas. Okay? Some of them, newspapers, wiki, blogs, emails, text, forensic reports, transcripts, and many things. Okay. Now, the three terms let's understand. Okay. Now, cognitive is different from traditional applications. Okay. What is understanding? In cognitive systems, it understands like humans, whether that is through natural language processing or written something words or speaking something or showing an image. So essentially, you have to understand understanding is a basic feature. Okay, how you understand? We have learned a couple of things, this machine learning thing. So essentially, apply those things we understand. Then we talked about reasoning. So it's just not understanding is enough. They can understand information, but also the underlying ideas and concept. The reasoning ability is significantly important for us. The reasoning ability can become more advanced as we move over time. New techniques will be applied. Then its difference between the reasoning strategies we use, just like children's, they try to solve the mathematical problems in their early days, elementary schools. So same way you have to strategize, then develop our reasoning step by step. Okay. So when you design a machine, a reasoning capable machine, it has to do the same thing. So we need machine learning, deep learning, and above that, knowledge graph, and so on forth, so that we can get able to make a reasoning without conflicting, any conflicts. What is learning? We discussed that many times, that it never stops, learning never stops. So that's why all kind of supervisory, unsupervisory, semi-supervisory, incremental learning, they're all coming up, and they will not going to stop soon. Okay? So as you see, we are in a path, we're still trying to find a clear understanding of the object and developing concept, then go for reasoning. It has to be more refined, and learning never stops in this process, which are pretty much important for your cognitive IoT. Just like a child after birth, they learn, they reason, they keep moving, building their cognitive ability, same way, sometimes throughout the life. We do that, okay? Same way, you design a cognitive system that should do exactly the same. Not that you design something, it stops doing, it learns, it does everything, it's done. Okay? So it's a continuous promoting and keeping updating itself with new architecture, new algorithms, and self-evaluation has to be there. Now, cognitive is driving new capabilities. True, right? Just like it, when child was growing, oh, we become so happy, parents become so happy, he's walking, laughing, talking. Okay? So same way, new capability for your engine that you're going to make with the cognitive capability is something like that. Little fun about cognitive IoT applications. They're very rudimentary. Okay? Suppose you step out your home. Say, I step out of my home, and the home power, electric power, turns into a power save mode. Then I step into the car recognizes me. My car's seats are automatically adjusted. My favorite music station is set. Playlist started. The news aggregated is displayed or can be told to me. A dashboard can be read by somebody. Okay? I am traveling, then it tells the weather forecast of my destination or on the way. All those necessary things comes itself on my way. And if I pass by a mall, then the car reminds me anything I have to purchase that was previously stored somewhere. And I sync my digital card so that the purchase can be made quickly. And we need to move around and finding things that we need to bring into the cart. When I come back to the car, I start interacting with the car in natural human language instead of typing numbers or address where to go or search things. Then I ask for good places for lunch, which I have not visited. So based on my previous experience and cuisine preferences, rating from third-party sites, set of recommendations are made to me, I choose one of them. Then GPS devices are synced based on my response and direction changes. An alternative route is selected if there is a traffic congestion somewhere on the way. I have lunch, I don't need to carry cards, I am being recognized, so then I go and best credit card of, after checking all available offers at the restaurant comes to, then I can choose to use. So my digital wallet knows this thing automatically, use the particular card that benefits me. I come back home, lights are back, all device started, then I say good night, lights are dimmed, and the clock is set to wake me up at 7 o'clock. This is just kind of a fantasy. It's not real fantasy. They are very much already there kind of things. Okay? This seems like maybe 5 years back fantasy, but now it is all so common now. So what is cognitive computing? The cognitive computing refers to a system that learn at scale, reason with purpose, and interact with human naturally. Simple, okay? Learn at scale means it's not that learn this much and all the time it learn this much. It learn and learn and learn, it expands its scope. Reason with purpose, not a random way. It a reason with for clear reasons, clear purpose. Then interacts naturally, just like human being is not machine to machine, machine to human. It's like no, as if human. Rather than being programmed, they learn and reason from their interaction, from their experience with their environment. This is a definition John Kelly stated, and people liked it. So these are the features of cognitive computing solutions. Okay. Now, these are adaptive, interactive, iterative, and stateful, contextual. Let's look at them. Feature, adaptive. Adaptive means it's going to mimic the ability of a human brain to learn and adapt from surroundings, just like a child does. Okay, it learn and adapt. That's the feature necessary for your cognitive behavior or cognitive quality to the system. Interactive, interact with all the elements in the system. Like a system is defined as processor, device, cloud, and user. Okay. Could be visual too. Okay. Then third feature is iterative and stateful. Remembers previous interaction or experience in the process and return suitable information. Okay. That's iterative features. Contextual, they identify contextual elements such as meaning, syntax, time, and user profile. And it is pretty important for any cognitive system. That way, you are not doing something misguided way. What are scope of the cognitive solutions? There are several scopes. In fact, a few of them are engagement. That is, its ability to develop deep domain insights and provide expert assistance. Okay? It is capable of making decisions in an automatic fashion using reinforcement learning. And also, it goes into discovery mode. The system should remember previous interactions in a process and return information. This is your discovery. Again, as usual, for various things are given the providers. Here are actually cognitive providers, platforms that pretty much being used. See, they're all cognitive. They're same. Google has called DeepMind. This is a small company in Texas. They also pretty popular in this because Parkinson's, cognitive scale. They're some of the platform. All platform has not come up with the cognitive scope, but this, or some of this actually, in forefront. Now, coming to cognitive IoT, there are two pictures essentially. It's showing actually the traffic is congestion, how cognitive IoT helps. This guy is coming home after work, then how his couch, so everything is kind of set for him, and he's watching TV. Maybe after watching TV, he can sleep. If he sleeps, the couch has to spread itself. Those kind of things that based on what we discuss, something like that. But cognitive IoT has two objectives. Okay? One is bridging the physical world and social world together. Okay? Then enabling smart resource allocation, automatic network operation, and intelligent service provision. So they're all coming in the broad scope of objective of the cognitive IoT. Let's look at the framework. Okay? Now, this framework is about something like integrating human cognition into the design of IoTs. It's similar to that. It's like that. So it has got actually 4 layers. Okay? Sensing control layer, just like we have IoT, several layers, network, several layers, AIoT, several layers. We have, for cognitive framework also, 4 layers. Sensing control layer, data semantic knowledge layer, decision making layer, and service evaluation layer. We'll go each of the layer and see the scope. Now, as it looks here, in sensing control layer, this is the physical environment. Things, objects, and resources are there, right? And it's giving the perception and sensing things here, getting data and heterogeneous system, and this sensing could be large scale, which means a lot of sensors are producing data as catching up. Okay? Now, at the same time, a sensing layer, the feedback coming from top is coming here, we call action adaptation. So action, it gets actually input here to actuate, sensor output here, physical objects and physical objects as actuator get the instruction from this way. Okay? That's essentially sensor and sensing actuating happens here. Then you go to, let me go to the one by one possibly, then you come back. Okay? In second one, data semantic knowledge layer. What it does, it effectively analyzes the sensing data to form useful semantic knowledge. Okay? This is what we're talking about. Analyze data and get semantic knowledge out of this data. That is called data semantic knowledge layer. Okay? Then third one is decision making layer, where again semantic and knowledge data abstracted from a lower layer to reason, plan and select. And the most suitable actions they do with a dual functions to support services for human or social interactions and stimulate the action, okay, to physical environment. Go back and see what's going on there. See. Yeah, this is a decision making layer. So from semantic knowledge, it goes there. So more algorithms are acting here to make decisions. Okay? In fact, we'll talk all this in little detail going further. Okay? So here we're trying to see the relationship between all those layers. Then we go back and talk a little bit details of these things. Decision making takes place here. At the same time, it also gets something output from top social network layer, or some we call that broad service layer. Then if there's the actuation has to happen, follow this route and acted here. Or it goes to the service provisions and move to social layer. In service evaluation layer, it shares important interface with the social network in which on-demand service provisioning is made, and novel performance metrics are designed to evaluate that layer, and where feedback evaluation or an action to be done at the physical layer. Now, how data analytics being done in cognitive IoT? Your massive amount of heterogeneous sensors are there, which generates raw data. Okay? This data could be corrupted, they may have a noise, they have varieties, they are multi-dimensional, and sometimes nonlinear separability property built into that. Basically, you get a set of data, structure on structure, and kind of could be any direction, could be wrong. Then you get to the next level here, we call that actually massive data analytics stage, and these are some of the ways we process them. Okay, I'll give you one example here. The rest of you basically I will skip for the time, and the paper I have cited in the first slide, they have all other details actually. And that way, data being collected here could be coming out as organized data, because this data is pretty much unstructured, unorganized. We need to organize it in following ways. Now, when the first type is heterogeneous data processing. Data type could be text, video, and voice. Sometimes we call actually multimodal data. The multimodal is a separate topic. Probably will take, I think, next one of the lectures. Then, when data types are like this, then data processing could be also accordingly changed. which means sometimes you get data, they have to be put together, we call it data fusion. Okay? So data processing happens by doing the data fusion, or sometimes you can do classify data, deal them separately. In many CIoT applications, the problems are often modeled as a multi-sensor data fusion. Also distribution, estimation, distributed detection, because the architecture is typically distributed in nature. In this case, joint probability density function PDF, f of g of the heterogeneous data g is needed to obtain from the marginal PDFs. So this equation is typically used for that. For now you can ignore this, just tell that there's a mathematical method to do the analysis. For heterogeneous data processing, capulas means connect. Okay? For heterogeneous data processing capulas, so the capulas function is used to connect multivariate joint distribution to the marginal distribution function using Sklar theorem. Paper has details. Now, if you remember that in the second stage, second layer, semantic derivation knowledge discovery layer, what happens? Now, since we are getting a large scale of data, it is still infeasible to utilize such a huge amount of data and analyze them straightforward. Okay? And if you try to do that, first of all, it's complex, then you will be inefficient result out of that. Now, if the objects within CIoT are able to understand correctly and reason properly, they can behave appropriately, which means we have to be careful how to handle this data. Okay? Now, future smart traffic signal, in the example, future smart traffic signal light, they don't have to have a light for sake of physical light. They can understand the vehicles coming to that point, crossing point. They can know status of the vehicle, such as speed, direction, okay, and type of vehicle, and they can take a call when to cross it. And if they can identify, they should identify vehicles, then they have to give way to do those vehicles before crossing the cross point of the traffic. And using those information, they can discover or decide their own signaling pattern, whether to move or stop or slow down. This is an example showing, okay, they have a lot of data to process before do that, to make the future trafficless or smart traffic to be there. Typically, what you see the framework of a semantic derivation and knowledge discovery is like this. They get analyzed data, and there are two types of data. They basically divide that into two types: semantic derivation and knowledge discovery. And each one is processed their own way. For semantic derivation, they use they process it and follow up with the context. They refer context, data context, ontology, and standardization. We'll talk about this thing next slide. And also we'll talk about knowledge discovery, what happens in knowledge discovery. So which means the raw data, after cleaning and structured or semi-structured, they have to go through these steps, okay, to get the semantic data. And same way, they have to go through these steps in this direction to get the knowledge. Okay. Now, semantic derivation in CIoT. Okay. Now, semantic derivation is defined as the process of deriving semantic meaning by adopting various kind of semantic technology from analyzed data. So you have to apply many technologies to do that. The key concepts are context, ontology, and semantic standardization. So what is saying that to get the real meaning that semantic, we should consider these three things at the least. Okay? The context is any information that can be used to characterize the situation of the entity, such as place, time, location, all those things, or identity, things like that. Okay? And since the source contexts are massive and heterogeneous, there is possible that we can get into identical situations, and that should not override the intention. So there's some way to come up with a unique semantic, but sometimes not possible. We might get a similar semantics. Then you can discern those things in a different level. Then next one is a ontology. So ontology is a formal and explicit specification of a shared concept. Okay? And this as conceptualization means it refers to actual abstract model of some phenomenon in the world by having identified the relevant concept of that phenomenon. Don't worry about if you can't digest quickly. So ontology is about, okay, you must have seen like, ontologies for birds. So that different birds, it's kind of everything about a particular domain has been clearly titled. Okay. The various names for same bird, different names, they have been spelled out. Sometimes ontology is available like a tree structure also, sometimes in vertically labeled also, it's database. So basically know that say database with it is for the semantic. So that means semantic ontology, they are hand in hand. You want a semantic result, inference, then meaning, you have to follow. One of them is big thing is ontology. It's because in different part of the world, the same entity could be named differently. To give a perspective there. Then you have semantic standardization. That's essentially, you may get different things, but you have to come up with a standardized term for that. So only when you do standardized meaning, and then it's possible that I can talk to you, which means you are talking about a particular entity. You know that you are thinking something, I am thinking something else. So ontology makes it, gives the details, then standardization takes the way, oh, I understand, Mr. X talking from this place about this, and Y also talking the same thing. Okay? So using standardization approach, the ambiguity will be reduced or minimized. Although many different semantic standards may coexist, there are a lot of work going on at various parts of the world. The use of ontology-based one is enabled to map and cross-reference, which means ontology happen to be the main source of confirming this is the right thing. Then we did the left part. We did this one, which gives semantics. Then let's look at the right side. This one, right? So knowledge discovery from analyzed data in CIoT. How do that? Now, in smart transportation example, which one? Remember that there was a picture. We'll go back. This picture. Okay? People are going, there's traffic, you see it's kind of a standstill, they're going slow. Yeah. Now, in smart transportation example, crowdsourced observations on the street is a raw data. What is crowdsource? You are driving, you have a phone, you can tell, sometime if you have GPS, they usually find some abnormality on your driving, abnormality on the speed and stuff like that. They pops a question. What do you experience? Do you find it is congested or not? at what level, very quick. And in certain time you have to respond that. If you don't respond, that's okay, but you can respond it quickly, what is going on there. They ask a question, you answer yes or no. That's how your Google get the data from there. And they get from a lot of people. That's called crowd sources. So crowd-sourced observation on the street. Then at the same time, since they have control, observation control on every vehicle on that map, on that area, they also have real-time data. And that's called analyzed data, because this is they have. Okay? And this data is context data for this crowdsourced data. So this is raw data, this is analyzed data because this is their data. This is the data crowdsourced. Who knows, somebody will make a wrong input. Okay? So they call this raw data. They have a choice to maybe ignore some data depending on some parameters. Now the analyzed data, raw data. The meaning of whether it is jammed from start to destination or a part of the street is a semantic observation. The meaning, do you call it a real jammed, entire street, or maybe part of the street? And then predicting that, they essentially give you a red line in that jammed area. You must have seen that, right? Then from the analysis, they also can find out and tell you the average time. They say that, oh, you are supposed going, you have to cross that area. Then delay will be, say, 10 minutes. They say plus 10. Have you seen that? So this is exactly, they analyze, they say, average time for 20 adults to pass the traffic in 30 seconds, analyze this thing. This is knowledge. Now you got it? How knowledge is formed? Using crowd sources, smart transportation example. So AI, machine learning, pattern recognition, database, these techniques are applied to discover knowledge from particular example. So you take another example, then to be similar way, different terms. Now, what are the techniques for knowledge discovery techniques? We saw that in that particular slides. One of them is the association analysis. Okay? There are three kinds of association analysis: multi-level associations, multi-dimensional associations, and quantitative association rules. In multi-level associations, if you look at the same example, you may have meanings at different levels, such as street level, or city level, or country level, and so on. Okay? Now, multidimensional, it involves more than one dimension. Sometimes time. This example says, okay, rules that relate to how much time it costs for a passenger passing a street to width of, say, 60 meter, 100 meter, whatever, or 100 feet width of the street, and or the passenger's age. Why? Because is a old person might go pretty slow. You don't have, the width is not really connected to that. Okay? So the two are completely orthogonal, who knows? So multidimensional analysis means you might have to analyze various ways. You do not know which one is useful. Okay? And sometimes unnecessary computation also will be kind of extra work. So you may be just doing the context and then do the multidimensional associations. Even if you have possibility of doing this way, you might not be doing this or may not doing this when you're looking for this. So techniques for analyzing such associations should be chosen according to difference in how they handle repetitive predicates. Okay? So what is saying here that your association should be chosen such a way that should have a merit to handle some questions that's coming up again and again. Then the third type of association rule is called quantitative association rules, which involve numerical attributes, measures which have an implicit ordering among values, time, street, width, or age, as mentioned before. So it could be a different example. The reason of giving same example is to kind of connect it and correlate it. Okay. Now you can have a different example, then this might change according to the example. So, but in summary, the quantitative association rule involves the actual numbers that you measure, and they are well connected to your problem. Another approach is called clustering analysis. Clustering means grouping. You analyze data that is partitioned into subsets, that is also known as cluster, such that the analyzed data in a cluster are similar, yet dissimilar to the ones in other clusters. So your clustering has to be more effective so that each cluster has a different region to show something. Okay? Such as it belongs to a senior citizen or belongs to a regular group of ages, or you are some of the people suppose driving on the street, then you can say going in north or going in south, the speed category. There are so many possible ways you can cluster them. In CIoT, different cluster method may generate different kind of clusters on the same set of analyzed data. Okay? Depending on how to approach that. It's very easy to understand anyway. So example, one can count the number of vehicles and the number of passengers separately to cluster them. How many vehicles and how many passengers. And this is different when one counts vehicles and passengers based on their heading directions. Okay? Knowledge discovery also possible to outlier analysis. This is very interesting. We always use this actually. And outlier means something don't fit the scope. Okay? When some objects do not comply with the general behavior or action model like others, these objects are considered outliers. So what to do with those things? You throw them out because they're unnecessary things. Okay? And that also saves energy and time. Okay? Suppose you are doing some clustering or doing some analysis and you know that there's a valid limit, lower limit, upper limit of certain activities. Think about you are judging that how many people are visiting doctor's place, then their age-wise. Some age come 210. So that's outlier. Just throw them out. Okay? These are the simple steps to get data cleaning, you can call it, but they're all in a way helps knowledge discovery. Now, intelligent decisions is basically making for cognitive IoTs. So decision making is important. That's basically IoT, CIoT is there, right? So decision making in CIoT involves reasoning, planning, and selecting. What is reasoning? Reasoning and planning are nothing but data analysis. The selective decision making, the one you choose an action from set of actions. And there are three kinds of cognitive selecting, so especially you can say a Markovian decision process, multi-bandit problem, multi-agent learning. Okay? And these two are selected. A single decision maker, you can have a multiple decision maker here. We are not discussing details of those things. Just now, as this diagram or framework shows, in the last few slides you saw that we got semantic information and also knowledge. Both are now input to decision maker. And you may have several of them. So you get multiple decisions. Then you have to apply which decisions you will be choosing from. Okay? So it's talking same thing actually. Semantic information generated from semantic derivation, while knowledge is obtained from knowledge discovery, and they are given input to multiple decision makers in CIoT. Selections of the decision makers is interactive. Basically, you can choose which one. Okay, to capture the interactions among multiple decision makers, one would formulate the problem of cognitive selecting game. So when you have got multiple possibilities, you have to make a game theory to get the right ones. That's a standard technique for, in AI. Okay? It's a formulation actually, and we have not included any of the solutions because there's so many possible game theory can work. That is also another research problem. Okay? So what are the limitations of cognitive computing? Okay. Limited analysis risk is going along, it will go a long way. Due to culture, socio-political influences, you can analyze certain things. Okay? If you are doing something about population related things, then you may not say age could be a reason for employment stuff, or a particular category of people be included, and that details could be also provided to analysis that might be offend, and the political people, they might make noise. But it don't matter. In India, I have seen so many things happening, so who cares kind of things. But when it comes to industry, comes to some business, one has to be careful. Okay. Everyone don't have this equal freedom to say things, unfortunately. Now, meticulous training process. We have many training techniques adopted. Not necessarily all of them are perfect. In the growing data set, okay, particularly any training you do, these are very laborious process. And quite often, the data are not updated on time. Sometimes there are too much of data to be handled with. So this area is weak, because if you are able to process this well, then your cognitive decision making capability is better. Then more intelligent augmentations. We discussed several augmentations today in the first lecture. Okay? And you always have to increment, because you have to keep learning, you keep adding the new data. Incremental learning is something you have to keep pushing so that intelligence is built up into your cognitive IoT system. Okay? So AI problem complexity is a challenge for that. In summary, your CIoT has truly drawn a beautiful and exciting future, though current researchers and developments are still far away from that vision. A long way to go, in other words. Cognitive IoT would empower the current IoT with a brain for high-level intelligence. Basically, we are in the process of giving brain to the objects to make them genies. Okay? Okay? Now, where general objects cannot only see, they can hear or smell, but creating data, but they can also take a decision. They can have to think and understand the physical environment and social world by themselves. So we finished much earlier, 40 minutes or so. Yeah, questions?
Any questions?
At least in framework is kind of available to us now, and research can be happening on that framework.
If there are no questions, we will wind up this session. And at 12:15, we are going to start with the interaction session. So I expect all the participants to do this exercise that I can.
So So you have to set the other ones for me. Okay, you said other. Sure.
And I can operate from here.
Who is that? She can sit down. You can sit down up. I can talk here because, yeah, yeah. I can be here. You can be there. You can switch the place.
Yeah, that's, yeah.
Yeah. Let this off so that I can move and talk.